The internet. It's filled with pictures, but not every picture. What about this picture of me? Well, now it is, but not every possible picture is on the internet yet, so I'm going to try and change that. Now, you may be wondering, Cooper, how on earth are you going to brute force every single image to ever exist on the internet? That sounds impossible. And to that I say, yeah, it probably is, but let me explain how I can try. It's time for a stop motion explanation. So, in order to put every image on the internet, here's the plan. Each pixel on your screen is made of 3 colors: red, green, and blue. For the sake of creating every image ever, all we have to do is turn on each pixel color in some pattern on the screen. This pattern could be the following. Start off with all pixels off, or black, and then turn on only the red color. After that, we turn on just green. Then we turn on both red and green, which combine to make yellow on your screen. Then activate only blue. After that, turn on red and blue, making magenta. And then activate green and blue, making cyan. And finally, turn on all 3 colors to make white. This combination of movements isn't random, and it's called a binary counting pattern. This pattern will give us a methodical way of going through every possible image. But currently, this pattern is only for 1 pixel. However, it's pretty easy to extend to multiple. Once the first pixel's pattern reaches white, we set it to black, and then start a binary counting pattern on the second pixel. Then we start another cycle on the first pixel. Once it reaches white again, set the first pixel to black, and then go to the next color in the pattern for the second pixel. This strategy can be repeated until the first and second pixel reach white, in which case another pixel will need to be added. This will allow us to use as many pixels as we want in our image. So that's the plan, but there are a few limitations to brute forcing images this way. Number 1 is the available colors. Normally, pixels don't just turn on or off, but rather fade in and out. Since we're only going to be turning them on and off to make the program take less time to complete, we'll be skipping a few images. You can actually see this effect with this model I made. Here, the red, green, and blue pixels can fade up and down, meaning there's multiple states between the on and off. However, this model would be like the one I described earlier, where the lights only have 2 states, on and off. The second limitation to this project is it's really slow. I'm not sure exactly how long it's going to take, but it's running at 100 frames per second, and it has about 2 raised to the 691,200 images to process. I'm honestly expecting this code to break before it finishes. And speaking of code, ladies and gentlemen, boys and girls of all ages, it's the moment you've all been waiting for. It's time for a code reveal! So, the way the code actually generates images is based on the Unix time epoch. This is a number that has been counting every millisecond since 1970. Based on this number, we can assign a unique image for every 10 milliseconds the number counts. This 10 millisecond delay is for the animation of the images. That way your computer can render the pictures. This does mean that the images will be live, and once you see an image, you'll never be able to see it again, because the program overwrites itself. This is a good thing, because if we had to store all these images, that would also be impossible. If you'd like to check out the webpage I made that brute forces every possible image, there's a link in the description. Also, this program won't start running until January 1st, 2023 at 12 a.m. So if you want to see it in action, you'll have to wait till then. Anyway, thanks for watching.